Hello everyone, I'm Xiaogang. Well, we've basically finished writing it, so let's just test it now. Because in our message, we've actually done several episodes on this part, but we haven't done the result yet. We can only work on the result after we've completed this part. So let's start testing now. For the test, we can actually see in our logs what kind of information we receive each time. And then, and finally, actually, after we pass the test, we might, in the next lesson, write the code for this result. This layer of code, this chapter should be finished, and then, there shouldn't be too many issues. Okay, so here, we'll still use our key 1 and key 2. And this agent, we can monitor it, but we definitely won't be able to listen to this proxy. So we can give this proxy a customer. Actually, it doesn't matter whether we listen to it or not, because for this log, we will have a log to record this closure. So we'll just mark it as closed. Okay, for the drywall here, we'll just write something casually. We'll give a code and a reason, right? Then we'll give a close action. There is an evoid, and this evoid is special. We need to stream it. Okay, now press E to start. Then let's test it again. Okay. Hello everyone, I'm Xiaogang. So we have now received this real-time audio response data. You can see this data is responding quite quickly. Now let's turn it off. Okay, so what exactly is this data you receive? You can see the data here is quite complex. It contains a lot of information. Now we will pass the response of this result. We'll just pass it out for everyone. Let you see. Here, this stuff looks too headache-inducing. It's actually just this. Don't waste your time writing this. I don't think it's necessary. Because this saying is essentially structs, nested within structs, nested within structs, nested within structs, right? The reason it does so many things is probably to provide you with more detailed information. It only appears after translation as enabled. We haven't enabled translation, so this data might not be available. Okay, now, let me show you how we handle this response information. Since our test is fine now, let's start writing this response information. Then come here again. Let's turn to our result section. First of all, our response information is quite extensive. Our writing method here is quite special because it may involve the translation field, which is a bit strange. So we prepare an object here. This is the factory we prepare. We create a read stream. The data read by the read stream is obviously parsed here. This part ahead is already very long. Let's hide it as much as possible. Let's hide the start directly. Let's hide this L directly as well. Okay, here, then let's create a read stream. After creating the read stream, we deserialize it into an object called JSONObject. Then we check if it has the biz field. If we find the biz field, then it's easy for us because it simply enables the translation feature, right? So how do we do it? If we find this biz field, okay, then we definitely need to prepare a translation data here. Let's see if we have prepared the struct for this translation data. Obviously, we haven't prepared this translation struct here. Let's move it closer. Okay, so what does this translation struct look like? What does it actually look like? It actually looks like this. Let's change the name slightly. Also change the export red to avoid any conflicts later. Okay, let's cut it off like this. Okay, so this is the data with the translation. Obviously, what do these translation fields mean? That is right here. That's all this field means. Okay, we don't care what these mean. If you're interested, take a look on your own. Because we're not here to guide you through making this. Then, with this thing in place, we come back. We come back to our place here. Back to our place here. It proves that we have 300 million pieces of data. Then we need to do a conversion job for an object. Such a conversion task. Of course, the conversion work here Definitely very successful. Why is this conversion different from what we saw before? Need 2 more zeros. This is because we cannot guarantee this version such compatibility. That is, we just wrote this 0 in because some versions have these 2 fields, some don't, so we just wrote them in. And then this place can definitely be parsed successfully because it has already found this field. So if the 1D here is greater than 0, we can see here how do we do it? That is, if this 1D is greater than 0, that it means we have already handled it. Then we do this. We take this. We have prepared 2. It is the translated field and the original field it translated. You can see. Then we print the log like this for everyone's convenience to see. But currently this code definitely cannot be used because this translation function is no longer available. But we leave it here, then print these 2 fields. Then we prepare sanctity information. Then we put it back. And you can see, obviously we don't have it here yet. So we add this information back. We need to put this information back for him. So how do we define this information? Let's go to our definition area. This is the information. Obviously, it will return a step ID for this action and whether it succeeded. That is, whether it is available. This is one of our habits. And here, it's an enum type. We don't have this enum yet. So we need to write this enum. Okay, we can put this enum into, let's put it on top here because we need to base it on this. Because we are dealing with multiple situations, so we need to retrieve the corresponding struct based on the enum. Then we need to change this name. So this is the reasoning behind it. I think this part should be quite easy for everyone. This should already be written a lot. Then based on this enum, we will use different subsegments below. Some of them actually don't really want to mess with any enum or subsegments. They only need this one text. So we put this part and they include the text as well. And here we have also prepared a native information. What exactly is this native information? We can take a look. This native information is actually what we mean by the user might want to see more of this kind of information. So this native information, we put it up here. There is a bit of reflection here. That is the information from our original translation of these fields. Of course, we need to change the guide empty here and then change the name here. Okay, this native information should obviously be it. That is, in each of our cases, the corresponding original struct. So for the first struct, it should be this respot info. This respo info should be it. Then the second one is without translation, and that one with translation data, if we don't have it yet, we can comment it out. Look at this translation data. We should have it. We put this translation data here, okay. Then comment this one out first. The amount of data here is very large. Then after we finish writing this, we will explain it to you. Actually, this is the structure we ultimately present to the user, and they only need to care about these few fields. But some users may need some deeper fields, so they select the structure inside based on this enum. There are 3 structures here. These 3 structures correspond to these 3 enum values. Right, so this one contains the translated data. This part is the final data. This is the data flowing through the middle. Okay, good. So after we do this, let's go back to the subsystem. Actually, I'm a bit confused about this, but this one is okay because it doesn't involve much technology. You just need to spend some time sorting through this information. Oh, there is an ST information here. Then this async ID must be this. The result must be success. Then this enum type must mean this translated final field, the one with the translation and the original code, the one with the original text and the translated text field. So there is a respond info here. So this respond info, we can see it's definitely this one. Then the field we are translating should be this field. It's this one. This part is marked in red. Let's check what the reason is. It doesn't have this field selected. Then what we should comment out is, this is written incorrectly here. Should enable this one. Okay, that's correct. Now, Good. So actually the thing with the translation, we have finished parsing it. Everyone can take a look. That is to say, we just need to return this information back. Good. So after we take a look at it, we will hide it because we can't test this feature right now. Because this feature is no longer available. This is a paid feature. Okay, if we don't find it, that is, if we don't find it, it will inevitably involve something that might be transient, or it might be some intermediate data. So here, we prepare a piece of data that has not been translated. This struct is the one that has not been translated. Let's go back here. This is generally quite confusing. This thing is relatively complex. So actually, the data we should be using is this. It is called, and it is not translated. We changed it earlier. Okay, we don't have this struct yet. Then you can see this struct. At first glance, it is obvious. It looks exactly like this. You can see. It's like it's wrapped in many layers. I don't recommend you study this thing. Just copy it directly. Copy this part. Just paste this in. Then where should we write it? Let's put it above init information. This one has translation. Let's put this gravity here. Let's type a segment. Then we'll paste them back one by one in reverse order. Obviously, there's no translation. It mainly has a few fields. So obviously it has a side and an ls. So it actually corresponds to this. Yeah, corresponds to this. If you don't have some, just ignore them. It might also be that I added some fields myself. Obviously, this is the place. We won't change it. Don't change it. Here. This side corresponds to this. Okay, this is unload. I don't know what this is. Anyway, it's placed here. Then let's put this here. Then we need to change this name. This name is this name. We've used it on our end. We'll just hide it. Otherwise, this would be too long. Can't view it either. Better delete this comment. Next is the CN. Corresponding to this CN, it actually corresponds to this. This really is just long and tedious. There's no way around it. Okay, this is our CN data. First, export the red one. Right? As for this struct, he should just change the front part. Okay, let's put it here. Okay, now it's the string field. You see the same field as another struct, right? Let's try again. Okay, then let's paste what we had earlier over here. Okay, this thing should be placed here. Let's take a look. It should be fine for the corresponding segment of Saint. Why is it showing red now? Let's check if it's placed in the wrong spot. This content data. Obviously, this is not CN. It's T. It should be this one. Just apply the minimum amount. Did we apply it wrong? Yes, okay. This wraps around this layer. Then next we write this RT. RT is actually this result. A result, good. So for this RT, let's do it again. Inside RT, it actually wraps another one. This VS. This part is indeed very boring. You can fast forward or get the source code yourself. Just copy and paste it. No technical skill involved. But you will find it painful to write. Okay. Let's take a look at this VS. This data should be this one. Congratulations, you're almost done. Now let's copy this VS data over again. Copy it over again. Okay, these trust naughty vis data here. The name here needs to be changed. This data should be it. And it has another struct wrapped around it here. Don't worry, I'm almost done. Almost done. I'll copy this struct over. Then let's change the name of this struct first. Alright, so this struct should be this CW's data, C. Then let's change the export. Okay, alright, basically this parsing is done. You can directly paste this and use it. I strongly recommend you do it this way. Then let's first make sure it compiles successfully. After pasting too much of this, I'm not too sure myself anymore. Let's just compile it. Great, it compiles successfully. Then we release this thing. So this is what we need to return to our previous data. It's the outermost layer. Actually, it's not exactly the outermost layer. Anyway, it's just an intermediate data. Then after this data, we start to parse and analyze the data inside. Prepare such a struct. First of all, we still need to serialize this data into it, right? So, for serialization, it essentially serializes the data in our response info. After serializing it in, we need to make a judgment because it could be intermediate data. Intermediate data is essentially transient. We just need to check this field. Whether this field equals 1, if this field equals 1, you can see there is a type here. Yes, look, if it is an intermediate result, we need to process it. If it is an intermediate result, then we just need to do it this way. We prepare a T-array like this. We copy it out. Okay, here we change the name. We just need to extract this intermediate result. After extracting it, we prepare this role type. Sometimes we have this role type. You can ignore this role type for now. You need to enable the character separation feature to have it. Then we make a for loop here. Then we concatenate this field into it. After concatenating it, what do we do next? We can return this intermediate data back into it. You might have questions about this. What does this role type mean? Because this role type is very special. That is, if the person speaking does not change, it will always be 0. If there is a change, when it detects the change, it will give 1 and 2. For example, when I speak, it might be 1 million. Then when you speak, it's 2 million. Then when I speak again, it's 1 million. So this role type is quite special. Everyone should check the documentation. This is not our main focus either. Then here, we will take what we have prepared. This data has been generated. As for this information, it's actually us taking everyone to look at it again. There's no way around it. This is just a commercialized thing. Once you do it, it's actually all very simple. But when the amount of information increases, if you don't write it well, it's easy to run into many problems. Okay, this is our intermediate data. So, as for this enumeration, we need to give it a piece of data in the form of this media intermediate text. And this part is what we recognize, respo info. Okay, so like this, we have our intermediate data sorted out. Good, now that the intermediate data is sorted out, this whole string is intermediate data. Then let's hide this part. And if it is not intermediate data, then we prove it is the final data. Then our approach is also quite different. So how do we do this approach? You see, this intermediate data, we have assigned the rough type like this. This rough type, or this rough type. Where does this rough type come from? You can see it is here. This field is, anyway, within this series of structs, you can find the rough, not it. Yes, that's it. This rough type is it. Yes, it should be it. Is there an RL here? You can see. Okay, here is an RL. So this one is quite special. Is this place our final data? Then we'll do the same as before. Let's copy this data over first. Then first create a default value. Okay, good. Here, we need to paste this struct. Good. Let's copy the data out. After copying it out, let's first make a variable loop. Put this structure into it. Good. After putting it in like this. After putting it in, let's log this, because this part is actually one of our final pieces of data. But the log level is not very high. Actually, we don't need to worry about it. If you need to, you can raise the log level. Okay. Alright, Alright, let's lower the log level a bit. Because the log level is actually quite high right now. We already have too much information. It will affect our debugging. So let's lower the log level. Okay. After we print this out, it's still the same. let's prepare such a piece of information. The difference lies in this part. The difference between this and the above. The difference from the above. It lies in this part. Each sentence changes, each of our sentences. It is no longer this media data. It is after the final recognition is completed. The only src of this file text. It is no longer the intermediate data because it is sentence by sentence. Then here, copy this thing. Okay, at this point, it calls our blueprint. So actually, our entire response like this is done. After compiling, it should be fine. Okay, the compilation was successful. Okay, in the next lesson, we will conduct a simple test. In this lesson, we have finished explaining all the final responses.